Hi, my name is George. I'm from Switzerland, and I care about quality. And so we all know how you get good software in practice. You test it, then you debug it, then you correct it, and then you go back and you test it, and then you debug and correct it. You keep doing this over and over again. And actually, this very community has produced a wealth of tools to help us do these things. And I myself am guilty of building tools for each of those three categories. Now, the reason I'm up here today is because it seems that we're making almost no difference in terms of the quality of the software out there. And it's a lot of fun to build these things, but could we have a greater impact? And what is it that we would need to do for that? How do we get the real world to use our stuff? So to answer this, I'll take a look at the real world and try to understand how the real world works. And I'll start with this funny bird. It's called a peacock. It's famous for its colorful tail, and it's a really big, massive tail. And this animal is a living proof that no matter how weird a trait is, if it helps you get the girls, it will survive natural selection. And a trait that will basically give you an edge over the competition, that will help you survive in some way or reproduce, it will actually win in the real world. And if it doesn't, it will not. This respected gentleman said hundreds of years ago, and free markets demonstrate that he was right for the past few hundreds of years, that if a product feature gives you an advantage over your competitors in the market, then that is a good product feature. And if it doesn't, then it's not a good product feature. So this is really a fundamental thing about the real world, that the stuff that survives is the one that gives you an edge over competitors, not if it's exciting or pretty or good in some abstract sense. So we have all these reliability tools, and the question is, do they really give us an edge? So yes, they help us build more reliable software, but does software reliability really matter? And I had kind of a wake-up call this past summer when a very respected member of this very community told me that the large software companies, they care about reliability to the point that they do not end up on the front page of the New York Times. So if they do not have a bug, they will put them on the front page of the New York Times, then their software is sufficiently reliable and sufficiently secure. And that's fine. The problem is that the New York Times criterion is not fine-grained enough to allow reliability to actually be a sort of a factor for competition in the market. You and I want software reliability, but how can the software developer that builds reliable software actually win in the market? The software developer needs an incentive to write the reliable software, and once they've built that reliable software, they need a way to differentiate themselves from the competitors in the market. Now, this question of how can you actually win using a particular feature is not new to reliability. It was the same problem over 100 years ago with respect to safety of various products. So I'm going to cover a case study here. The Underwriters Labs, I think most of us know about this independent product safety certification organization. You probably can't buy a lamp or a kitchen appliance or even a bulb that isn't UL certified today. So the UL started out in 1894 as a bunch of inspectors who were going out to electrical installations, and they were running tests to uncover potential hazards. Because back then, these things caught fire all the time and so on. Then, in 1903, they put out the first safety standard, and I think this is the first safety standard in the US for tin-clad fire doors. Like, how are you supposed to build this so they actually survive fire? And then 2 years later, they figured out there's a commercial opportunity to have a label service where you're allowed to put a UL certified label on your product if you allow the UL inspectors to come and watch you build that product in your factory. And today, they do standards and test procedures for everything, tools, materials, equipment. They even evaluate drinking water, the quality of drinking water. And Other countries have these as well. It's not unique to the US. Germany has the, I think it's called Technischer Überwachungsverein, which actually started before the UL. And many of you may not know, but no German registered road vehicle is allowed to drive on a public road unless it's TÜV certified. So the point here is that these certification organizations have had a tremendous impact on their respective industries. They've driven the safety standards up, and they made safety a criterion for competing in these particular markets. And the cool thing here is that many of these safety checks and safety certifications are not mandated by government. Some are, but not all. It's really driven by market forces. So what would it take for us to have an underwriter's labs for the software industry? Maybe we could have something like a TPC organization, right? The ones that build the database benchmarks. And they would test the software products out there automatically, publish the results, and enable consumers to differentiate these products based on their reliability. Companies compete on measurable things. They compete on performance because they're benchmarks for them. They compete on features because you can check them off a list. But they have really no means today to compete on reliability other than the front page of the New York Times. Actually, I don't know when crash testing was introduced for cars, but they get these stars, 3 stars, 4 stars, and so on. And today, you probably don't buy a new car without looking at these crash ratings. If you don't, you should. But maybe I hope that very soon you will not run software that doesn't have some form of quality certification. And remember, we care about quality. So, what would such a service need to do? What would it look like? Clearly, it'd have to be objective. I mean, this cannot be like a Consumer Reports or people sort of uploading their reviews on Amazon or some CNET reviewer going over your product. We have to have mathematical objectivity. And we can get this objectivity through automated test techniques that many of us are working on. These exclude the human subjectivity from the equation. Now, of course, this has to be a service that gives us a good cost-benefit ratio, so this should be inexpensive to operate. And I also think they need to work on binaries to circumvent issues of proprietary software and so on. Now, it's not enough for the for some government to just say, from now on, you have to certify your software. Okay? There's still plenty of technical challenges out there, and that's good news because this is fuel for systems research. I mean, some of these problems people have looked at for a long time and haven't been able to solve, and I think that if we come in with a systems angle and figure out the trade-offs, we have a good chance. First and foremost, we have to tackle path explosion for real-size software. I mean, this stuff has to scale to millions of lines of code, not 100 or 1,000. We're good at figuring out how to use massive clusters of commodity hardware to make things run in parallel. Leverage the cloud, right? Make automated testing go real fast. We should find practical ways to do automated proof generation. All this stuff needs to work for real software, not toy applications, right? We should support threads. We should be able to interact with the environment, have system calls, fail them when necessary, right? Real code. And finally, we need a practical way to specify and test for higher level properties. We know pretty well how to deal with low level stuff like race conditions and memory safety issues, but how do we specify and test the higher level stuff? Do we have to use higher order logic, which probably 5% of this room could actually use productively, or can we come up with something more practical? Maybe there are clever ways to leverage crowdsourcing. Maybe we can do a Wikipedia-style thing where people contribute their specifications. So anyway, I'll conclude, and I've tried to provide here some motivation for building this kind of a certification service. If we do have such a service, then this will give programmers a reason to build quality software and also means to differentiate themselves once they do so. And I actually think that if we believe in Adam Smith is if you actually put the certification service out there, then the market forces will redistribute resources towards reliability and give us better software. Of course, the players in the market have to be capable of competing, so we should give them the right tools to compete. And I also think we should make the tools easy to use. And the direction that I'm particularly interested in is making all these reliability tools we build available as web services. If checking for race conditions and deadlocks and other bugs was as easy as using webmail, a lot more people would do it. So, these services can run on clouds at low cost, produce high-quality results, and become accessible really to everyone. Whether you're a small 5-person team or you're Google or Microsoft or IBM, you have access to the same quality, to the same level and same power of quality assurance tools. So maybe if we do this, we'll be able to soon reduce bug density by an order of magnitude or so. At least that's my hope. So thank you, and I'll be happy to take questions.
Peter Chen, University of Michigan. So interesting ideas. You talk about this as a service for software in general, but I think you might mean a service per type of application, because the requirements are probably different per application. And the one example I can think of that does this already is antivirus, where there are these rating systems. So I'm wondering if you think that these independent antivirus rating systems have improved the quality of antivirus products.
Well, it's a good question. I mean, to be honest, I'm not thoroughly familiar with the sort of independent, thorough certification agencies for antivirus programs. I don't know how good a job they do.
Yeah, I don't think agency is right. I think blog is maybe closer, but there are some widely read ones. And they end up having some artifacts in terms of what they cause software to do. So they end up being tuned for those specific tests instead of real effectiveness.
Oh, right. So that's a good point you bring up, because one of the things that one might want to do, for instance, is to come up with benchmarks and say it's a reliability benchmarks. And people have tried to do this on and off for at least the past decade, and that is the time when you get an opportunity to really tune for that kind of issues. And what I'm proposing here is more the systematic automated testing tools that we've seen here, based on, say, model checking and symbolic execution and so on, which really don't give you corners to hide in. But yes, you could still tune, but it'll be a lot more difficult when you actually, do full path analysis and these kind of things. So I had more this type of ambitious stuff in mind.
Mike Friedman, Princeton. I guess I want to ask you more about your claim that this would allow you to differentiate yourself in the market. Because in the end, what you have is a certification of service which effectively is a checkbox. And so typically, when you want some type of market differentiation, you could show that you're different than your competitors. And if you look at the UL, the reason none of us look at the electronics we buy if it's UL certified, because effectively everything is UL certified. So we've lost the ability to differentiate between products in any way. And not only that, but usually the bar to pass becomes quickly low, and you often get regulatory capture. You mentioned crash star ratings. Effectively, every car now has 4 to 5 stars. The reason, because they test up to 40 miles per hour, even though front-end collisions are at 120 miles per hour. So it's true that we have these certifications, but it's not clear that they actually mean anything. And certainly it doesn't allow two products to differentiate if it's either a star or not star.
I think it's a good question, and to tell you the truth, I'd love us to get to the point where we are today with, say, electrical appliances, where everything's UL certified, and they're pretty damn safe. I mean, stuff doesn't just spontaneously catch fire as it did 100 years ago. And I think the UL has played a part in that. Now, how exactly do we have to design the certification service so that it provides some more fine-grained metric? I think that's a question that is still open. What I personally had in mind, and actually we built one tool that allows you to do this, is to do this automated testing and then literally just come up with a list of the problems. I think that by itself would be sufficient to say, okay, I have 2, 3 functionally equivalent pieces of software, and let me see which one is more reliable than another. So for instance, we've compared MySQL to Postgres with respect to their resilience to human error, human configuration error. And we found Postgres to be much, much better than MySQL because of how it's coded. Now, there you can have bars. You say, okay, this is 70% versus 30%, and you can actually compare products to each other.
Just one quick comment. Certification is not about trying to relatively rank which product's better. It's trying to say which one passes some approval.
Well, but you can imagine having levels, right? You're certified at level 1, level 2, level 3, level 4. The key thing is to be independent and objective and enable comparison.
Ivan Bashasnik, University of Washington. So I wanted to ask you about your motivation, because I feel like the certification services that you mentioned at the beginning, I feel like they've come to be through market forces, most likely because of human safety concerns. So, humans can die, humans can get cancer by drinking the wrong water. And for companies where that matters, in high-risk environments like NASA or, for example, embedded systems, people already do a lot of these techniques that you've mentioned. So I'm wondering whether people will actually care for the kinds of software that you possibly mean that people might be using in this room. When Facebook is inconsistent, I simply refresh the page. So do you feel like people will care when we have this rating service? So
it's again, a good question. If I may broaden it, I think it's sort of a subset of a harder question, which is, well, if you differentiate based on reliability, will that make a difference to the fact that people really care today about functionality and about cost and so on? And someone was saying, well, they'll just choose based on the same criteria as before. And maybe that's true. But the difference is that today they don't have any information about sort of relative reliability of things. So the goal of this service is really to enable them to understand the differences. If they choose to not care, which may happen, that's a possibility. I would like to believe that will not happen. I mean, at least there'll be more incentive for people to try to differentiate based on reliability and say, hey, my Office product crashes less than your Office product, even though maybe it has fewer features. I don't know.
One more question.
Golly. Oh, dear. So one kind of reliability, I'm Ari, UC Berkeley. One kind of reliability I care a lot about is resilience to the environment, right? If I run it on a different OS version or with different libraries or different file system layout, what happens? And it strikes me that that's actually the kind of thing you could test automatically, because in the cloud you can have 800 configurations which you run it on in parallel, and if it crashes on 100 of them, that's a really bad sign. Is that like the kind of thing you had in mind, or out of scope?
It's definitely not out of scope, but what I had in mind was actually going even further beyond that. So if you think about a product that, let's just say you have a text editor and it crashes on particular system configurations, there's an even more efficient way to figure that out than run it on the different configurations, which is to actually analyze the software itself. And so we're doing some of that work, and there's many other groups here that literally do this semi-exhaustive analysis of the software itself. So you'll figure out, for instance, through fault injection experiments that are systematic, that this particular piece of code will fail on the way the Mac OS actually implements particular system call, simply because there's something in the code that doesn't check for a particular property of the return value. So the answer is yes, that's what I had in mind, but not necessarily by trying it out on 800 different configurations, but by doing a mathematically rigorous analysis of the software.
So the reason why I mentioned configuration is that there's a lot of properties of configuration that developers rightfully rely on, which happen not to be documented and happen not to be formalized. Right? We actually know things about the file system layout in POSIX that aren't formal but happen to be true, and happen to be, by the way, specified so it's safe to rely on them, mostly.
Okay, so in that case, if they're well specified, then I don't think automated testing will actually flag them as being wrong. So I think that would be okay.